defining a trial, because I think that's the issue that we have when we are doing our simulations. So I think I've kind of figured out a technique to help you better determine how to describe your trial. So here it is. I think actually I've come up with that. When you have to describe a trial, there's really two situations. Okay? You are either going to have a question that's posed to you that says, out of a set number of actions. So maybe out of 5 boxes of cereal that you look at, out of 6 multiple choice questions that you do, out of 8 minds that you dig, what has happened? Okay, so you could be having a set number of events that you have to do. So your trial covers like that many every single time. All right? When you have that happen, the response that comes out of that, so the response variable, is going to be basically a yes/no answer as to if you achieved what the question was asked to achieve. Yes, no. Did you achieve what they asked you to achieve? So, for example, on this problem here, we were asked to draw numbers continue to be drawn without replacement. Oh, wait, that's not the right one. Let's look at this one here. Sorry, this one is what that has to. Dig 8 mines. So you dug 8 mines every single time. So the result that you were looking for, the response that you were looking for was yes, no, that those 8 achieved exactly 3 mines that had gold in them. Okay, so that was then a response that would be yes, no, I got exactly 3 mines that had gold in them. Okay, so then I had set since gold was a 1 out of every 10, so that's a 10%. I had left the number 1 represent a mine with gold. And so when I went through here and I did all my yes/no's, I ended up having 0 of them that had gold. So according to my simulation, there is basically a 0% chance of me finding exactly 3 of 8 mines that have gold. Okay. So again, that's the kind of trials where they say, out of this many, every single time, and you have a yes/no response. All right. Yes, question? The set number on that problem was out of 8 mines that you did. Okay? Yes. I had 8 because my mines were represented by 1 digits. So yeah, I had 8 numbers. And I ran 20 trials. So 10% chance of success. I let a mine be represented by 1 digit, and so then I ran 20 trials of 8 because it asked me to run 20 trials of 8. Okay. All right, the other situation is that you would be asked is to go until something happens. Pick numbers or pick boxes or pick whatever you're doing until you get you achieved a certain thing. You achieved getting a Tiger Woods prize out of the box. You achieved getting a mine with gold. You go until. You achieved giving out $300. Go until you got 3 tablets that were unsatisfactory. Okay, whatever. So if you have a situation where you go until an event, it might be like this number 1 that we had here. This one was one where you draw out coupons until the total amount awarded equaled or exceeded that 300. So first, because we had 50 coupons, mine were 0, 1 to 50. And so I ignored 51 to 99 and 0, 0. And because they were drawn without replacement, I also ignored repeats. Yes. you put that in another place, that's okay. As long as it's there. It doesn't have to be, we don't squabble over like where it is located. It's just, I'm giving you a guideline so that it helps you make sure you get everything in there. If you get it somewhere else, that's okay. Okay, so there's that. But look, our trial consisted of picking two-digit numbers until I get a sum of $300 awarded or more. So when I ran my trials, look at what kind of thing happened. These numbers were too big, so they didn't count. My first ticket, that was success, that ding, 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 ticket number 33, you got $50. Okay, and ticket number 47, you got $50, and then that one doesn't count. Ticket number 3, you win $200. And then at that point, I have gone until $300 has happened. That's the stopping point. $300 has happened. And so, I'm done. All right, in the next trial, again, these ones were all too big. These were numbers that I don't do. That one won 50. These didn't work. 50, 100. Look what happened here. We ended up with $250 here. So when this last $100 was added, it actually made $350. That's why in the problem it said equal or exceed a little bit. So then I was done, and so on. And I will show you on this last trial. 38 was my first winner, but I later came to another ticket number 38. Well, that one was not supposed to be back in the mix, so that one is not a repeat winner. Ignore that one if you get a repeat. Okay, now, like I said here, if you are going until something, then your response is typically how many items happened for you to achieve that goal. How many items happened for you to achieve that $300 you gave away? And so in this case, it said, how many prize winners do you expect there to be each week? So, how many prize winners in the first trial? 3 winners. In the second trial, 5. In the third, 4. And then your statistic will be averaging that. So I had that many averaged amongst 3 trials to get an average of 4. So according to my simulation, I expect there to be about 4 winners per week on average. Okay. I was going to say that if you also decided to continue your trials in this area, that's fine. You did not have to do them on separate lines. You could just continue on that same line. That's fine. Okay. Any questions about those ones? Okay. All right. Then let's now, I do want to mention that on this first problem with the 8 mines, the goal you were trying to achieve was your yes/no was did your 8 digs have exactly 3? But then look, when this changed to question B, do your 8 digs contain less than 2? So the response is now yes or no, I got less than 2 out of the 8 mines. So I really had to go back up and do a whole nother set of yes/nos. So I went back up and I ran through my 8 mines again with a whole nother rule of yes/nos. And I came up with 12 of those out of 20. All right. This is an important part right here. This connects to stuff we have done in the past. Did you connect that on part A, it's when it said exactly 3, then that's a binomial probability where you say 8, choose 3. Probability of success was 0.1, and I want 3 of those to have that success. Failure is 0.90% that did not have gold, and 5 of those do not have gold. So when you go put this in your calculator, it's your binomial PDF of NPK. And that came out to 3.3%, which is similar because I had gotten 0% according to my simulation. And so you can tell this is a very low number, close to 0%. Okay? And then this one is a reminder of how we did this before, where you had, we wanted to do, if we want less than 2, then I want 8 choose 0, and I want 8 choose 1. So you have a choice of either computing this as binomial PDF of HU0 plus PDF of HU1, or cumulative up to and including 1. And look at this percent, quite a bit higher, 81.3%. And when I ran my simulation, look, it was quite a bit higher, 60%. Okay? All right, last thing I want to talk to you about this homework before we go on to what you're going to do today is this. On number 3, this is a very valid problem that you would be asked to do. And I can tell you on AP, they would not give you this hint. They would not say, estimate with the normal probability since you have the mean and the standard deviation. That would be something that you would need to have come up with yourself. That you see, hey look, they gave me the mean and they gave me the standard deviation, so I think I can find the probability of getting a tablet with 8,500 units or whatever, or less. Okay, so you found this probability by finding the z-score. So here was my z-score, and then I norm CDF'd from negative infinity up to here, and I knew that this was about a 20% chance. It asked you to round to the nearest tenth, so that gave me about a 20% chance. Then I used that in part B. So I used this 20% in part B. Okay, now listen up. On AP, if say you get a brain block and you cannot do part A, you make up a number that sounds reasonable. Like you'll say, suppose this part's about 25%, or whatever it is you decide you want to make it up. Then do the rest of the problem and you with that number, and you will be okay. So if you get stuck and cannot figure out a number, make it up so you can do the rest of the problem. Don't let yourself not do the whole problem. All right. So that's all I wanted to say about this one until we go, I'll let you look at that deeper on Monday. But let's look at what you're going to be doing today. What you're going to be doing today is an extra practice to make sure you can identify these trials and get really strong at this. It's important to be able to practice these skills. So here we go. So on number 1, it's talking about cereal that has prizes in the cereal boxes. You can tell this is actually a little dated because the hero pictures are a little, we got Tiger Woods, he's still doing stuff, but we got Lance Armstrong, and then we got Serena Williams. Okay, she's still doing things, but they weren't in their prime like they were back when this problem was written. So, suppose that you buy 5 boxes of cereal. Okay, so let's go. Suppose you buy 5 boxes of cereal. Estimate the probability that you end up with a complete set of pictures. Simulate this with at least 20 trials. Okay, so what does this mean your goal is to achieve? A complete set of pictures would mean what? At least one of all 3. You at least get a Tiger Woods, a Lance Armstrong, and a Serena Williams amongst what? Amongst looking at 5 boxes. So, is this like, which one of these 2 situations is this problem like? A set number in the trial, or you go until?
Set.
It is a set number. It is like this, and you have a set number of 5 boxes. Good. Okay, so when you do your set number of 5 boxes, at the end of marking off those 5, what is your answer going to be? What is your response going to be after looking at those 5 numbers? Yes or no to if you got a complete set of pictures. Okay, good. Now, last question before we move on. The probabilities of this are 20% for the Tiger Woods, 30% for the Lance Armstrong, and the rest are Serena, which is 50%. So my question is, how do you think that this can be accommodated? Do I need to have 2 digits since we're talking 20% and so on? Or, how's the simplest way you think we can represent these numbers, these probabilities? Okay. just simplify this to one-digit numbers representing a box? No, not because you only have... Because it's related to your percentages. Because the percentages are in tens, 20s, 30s, and 50s. So because my percentages could be represented or divisible by 10, then I can do just one-digit numbers. Look down here. If you have percentages that you have to represent, such as 34%, that will have to be done with 2 digits, okay? Because you have to get into the ones place. So you would have to use 2 digits for this probability here. Okay. All right, last thing, and then I'm going to let you work. Number 2, suppose you really want to get a Tiger Woods picture. How many boxes of cereal do you need to buy to be pretty sure of getting at least one? Your simulation should include at least 20 runs. So what kind of trial am I looking at here? Go until you get a Tiger Woods. Good. So if you go until you get a Tiger Woods, what's your response going to be? How many what? I'm going to go until I get a Tiger Woods. What's the response variable for each trial? No? The number of what? The number of cereal boxes I had to open to get a Tiger Woods. Yes, that will be your response. And then at the end, you will average that response. Okay? All right. So that's a summary of your trials. I want you to work on these 2. Now, in class, I want you to pair up, because whenever you start counting all your 20 trials, it's going to be much easier if you have a partner that's like doing 10 of them and you do 10 of them, so that you don't have to do all 20 of those. So do that just to help you with your time so that you guys can get through them all. Okay?